Features of clouds, a comprehensive overview. Introduction. Clouds are visible masses of water, droplets, or ice crystals suspended in the atmosphere, playing a critical role in Earth weather and climate systems. They are formed through the condensation of water vapor and exhibit a wide variety of types, shapes, size, and behaviors. This document explores the feature of clouds, including their classification, formation processes, physical characteristics, and their significance in meteorology and climate science. Formation of clouds. Clouds form when moist air rises and cools to its dew points, causing water vapor to condense into tiny droplets or ice crystals. This process is driven by several mechanisms. Convection. Warm air rises due to its lower density, cooling as it ascends. Orographic lift. Air is forced upwards by terrain such as mountains. Frontal lift. Warm air is lifted over cooler air at weather fronts. Convergence. Air masses collide, forcing air upward. The condensation process requires condensation nuclei such as dust or smoke particles to facilitate droplet formation. Classification of clouds. Clouds are classified based on their altitude, appearance, and composition. The World Meteorological Organization recognizes 10 basic cloud genera grouped by altitude. High clouds, cirrus, wispy, feathery cloud composed of ice crystals, often indicating fair weather or in approaching storms. Cirrocumulus, small white puffy clouds arranged in rows, sometimes resembling ripples. Cirrostratus, thin sheet-like clouds that create halos around the sun or moon, often signaling rain or snow within 24 hours. Mid-level clouds 6,500 to 20,000 feet. Altocumulus, white or grey puffy clouds with a wavy pattern, often associated with fair weather or thunderstorms. Altostratus, uniform grayish clouds covering large areas, typically preceding prolonged rain or snow. Nimbostratus, thick dark clouds producing steady rain or snow, often associated with weather fronts. Low clouds below 6,500 feet. Stratocumulus, low lumpy spreading clouds usually indicating fair or transitional weather. Stratus, uniform low gray clouds that can cause drizzle or fog, often covering the entire sky. Clouds with vertical development. Cumulus puffy white clouds with flat bases, often seen on clear sunny days. Cumulonimbus, towering clouds with anvil-shaped tops associated with thunderstorms, heavy rain, lightning, and tornadoes. Physical characteristics of clouds. Clouds vary widely in their physical properties. Composition. Clouds consist of water droplet, ice crystals, or a mix of both depending on temperature and altitude. Size and shape. Clouds range from small scattered puffs, cumulus, to vast layered sheets, stratus, or towering structures. Cumulonimbus. Color. Color appear white due to scattering of sunlight, but denser clouds appear darker due to reduced light penetration. Opacity. Thin clouds like cirrus are translucent, while thick clouds like nim- nimbostratus are opaque. Altitude. Clouds form at various altitudes, from near the ground, fog, to the upper troposphere, cirrus. Role of clouds in weather and climate. Clouds are integral to Earth weather and climate system. Precipitation. Clouds produce rain, snow, sleet, or hail depending on temperature and atmospheric conditions. Temperature regulations. Clouds reflect sunlight, cooling effects, and trap heat, warming effects, influencing Earth energy balance. Weather patterns. Clouds indicate weather change such as approaching storms, cumulonimbus, or stable condition. Cumulus. Climate feedback. Clouds contribute to climate feedback loops, amplifying or mitigating global warming depending on their type and altitude. A special cloud feature. Certain clouds exhibit unique feature. Lenticular clouds. Lens-shaped cloud formed by orographic lift, often mistaken for UFOs. Mammatus clouds. Patch-like structures beneath cumulonimbus clouds, indicating stroke turbulence. Noctilucent clouds. Rare high altitude clouds about 50 miles, visible at telluride composed of ice crystals in the mesosphere. Contrails. Artificial clouds formed by aircraft exhaust, contributing to cloud cover and climate impact. Conclusion. Clouds are dynamic and complex features of the atmosphere influencing weather, climate, and human activities. Understanding their formation, classification, physical characteristics, and roles enhance our ability to protect weather patterns and address climate challenge. Continued research into cloud behavior is essential for improving meteorological models and mitigating the impact of climate change.